With their inherent flexibility and robustness to change, the decentralized interconnected knowledge graphs that lie at the heart of semantic web technologies are, as I will argue, ideally suited for the challenges of converting the messy, often incomplete, and internally heterogeneous datasets of the humanities, arts, and social sciences into machine parsable data. Although still a matter of some debate, the reuse and adoption of existing ontologies, schema, taxonomies, and vocabularies has been gaining traction across the HAS landscape for the last decade. My name is Dr. Terhi Nurmikko-Fuller, and I'm a senior lecturer in digital humanities at the Australian National University. I am recording on the lands of the Ngunnawal, the Ngunnawal, and the Ngambri, and I would like to acknowledge and celebrate the first Australians on whose lands I live and work. I would like to pay my respects to their elders, past, present, and emerging. In my talk today, I'm going to talk about some of the personal design decisions, practical solutions, and heuristics that I have implemented in a number of linked data projects within this HAS problem space. I'm also going to comment on the issues of political, institutional, and socio-cultural features that have affected the design, the implementation, and the evaluation of these projects. Humanities data is characterized by its nuance, the subtlety, the challenging ambiguities, and the inherent incompleteness of the dataset. The joy, the passion, the drive to solve these unknown mysteries of the past is what has inspired historians, archaeologists, art historians, ancient historians, classicists, and a myriad of other types of experts of the past world for centuries, if not millennia. At the very core of humanities scholarship lies the appreciation and the ability to factor those ambiguities and uncertainties into your analysis and interpretation. So when computer science methodologies are suggested that remove that ambiguity rather than capture it, these suggestions are countered by humanities scholars as a bit of an abomination. They are accused of being reductionist, of being reactionary even, and ultimately sitting in stark juxtaposition to the humanities research question. To put it another way, to simply fill in an unknown date as January 1st is an abomination to a historian, and at best shows a lack of understanding of what sits at the heart of humanities scholarship. So what then can we do? What can we do to capture that ambiguity, or at least to not remove it? This is where I think linked data technologies really come into their own. I will focus on some real-world linked data projects that I have had the opportunity to work on over the years. I will be citing examples of instances where unstructured data and the tacit knowledge from the minds of domain experts have been captured using the linked data process. But what is linked data? Well, it's not so much as a thing as it is a method. It's a methodology, it's a process, it's an information publication paradigm that utilizes existing web technologies and existing web architecture to publish information online in a machine parsable, machine processable format. Interconnected knowledge graphs enable software agents known as reasoners to navigate a knowledge graph and to infer implicit information from explicitly declared facts. This is accomplished by using the RDF abstract data model that has been developed by the W3C. What we do is we represent data instances in a given domain, as well as the relationships between those data instances using HTTP URIs. At the core of the RDF abstract data model sits the triple. Each of these is represented by a URI, except when it's not, when it's an integer, string, or a blank node. But in all other times, they are represented with HTTP URIs. The triple consists of three parts: a subject, a predicate, and an object. The object of one triple can be the subject of another, resulting in an interconnected knowledge graph that can be used to navigate through a wealth of enriching information. There are several different practical considerations which I suppose I have learned through the practice of implementing linked data projects across very different types of humanities datasets. Data in the humanities and the social sciences is often collected and stored in ad hoc solutions. It might be analog notes, it might be annotations on a page of a book, it might be in a spreadsheet, it might already be in RDF. In fact, we have projects that combine data from all these different solutions. The Elephant Project, or the early English print in HathiTrust, a linked semantic workset prototype, demonstrated the use of linked data in combining information from independent sources into a cohesive whole that could then be analyzed and accessed from a single point of entry. These datasets were the phase 1 of the early English Books Online text creation partnership and a subset of the HathiTrust digital library. In January 20, phase 1 of the early English Books Online, or EBO, were released to the public as TEI compliant, XML encoded, hand transcribed texts. We took this data and at the metadata level produced RDF so that we could combine it with a custom dataset from the HathiTrust digital library. Both datasets contain publications that have been published between 1473 and 1700. The key objectives of the Elephant projects was to generate RDF to export metadata extracted from the EBO TCP and then combine that with RDF produced by the HathiTrust Research Center. And we would do so by using appropriate ontologies and creating a prototype user interface through which scholars could seamlessly investigate the combined linked dataset. The workflow applied for this project consists of 6 separate steps. Step 1 was the consultation workshop, asking for the opinions and research questions that domain experts and librarians would be seeking to solve. Step 2 was the technical analysis of the metadata requirements and the ontology selection. In the end, we opted to adopt several classes and properties from existing bibliographic metadata ontologies, including mods and mads from the Library of Congress, as well as BibFrame. We also had to create some custom classes and properties. Step 3 was the selection of appropriate tools for the generation of RDF as derived from the EBO TCP, or the Early English Books Online Text Creation Partnership. We predominantly used 2 tools, one from the University of Southern California called WebComma, which works very well with tabular data. It requires much original investment from the human scholar or researcher, but produces very high quality RDF at the end. Step 4 was the population of a virtuoso triple store with the RDF produced from the Igbo text corpus. The elephant virtuoso triple store contains over 1,137,000 triples. It has 250,000 entities, 66 classes, 214 predicates, 287,000 distinct subject nodes, and almost 300,000 distinct objects. The Elephant Project was a fascinating case study example because the data that we worked with was based on the information provided by the original historical source. So these are texts, volumes, published pamphlets written between the late 1400s and before the start of the 1700s, so all historical text. This is a time when metadata standards have not exactly been standardized. And what we found was a staggering diversity of expression even within a single category of date. We have almost 100 distinct expressions of author date alone, again in a collection of just 25,000 records. There were over 1,500 distinct expressions for publication date, which we passed down to 54 different types. There were over 20 distinct types of information in the header, over 700 unique places, over 6,000 expressions of person, and for almost half of them, we were able to find IDs from external authority files such as VIAF and the Library of Congress. Institutional policies, however, dictate that only the early English books online or Igbo data is available to the public. This means that even the RDF produced from the HathiTrust metadata cannot be made publicly available. It can feature in the analysis and it'll affect the search results that are displayed in the Elephant Project prototype user interface, but the material itself is not available. And this is a very interesting case study example in how institutional policies can affect linked data projects. Transforming musicology and its sub-projects were an interesting opportunity to bring together very disparate, very different, but complementary data sets looking at musicology, digital musicology, and musical performance. This project, or this cluster of sub-projects, was also an example of the ways challenges can be presented when working with legacy, either tabular or relational datasets that don't necessarily natively facilitate linking and referencing to and from external sources. One of the sub-projects of transforming musicology was In Concert towards a collaborative digital archive of musical ephemera. In Concert was already a project which amalgamated information from various different data sets. There was the calendar of London concerts from 1750 to 1800s, and there was also 19th century London concert life. The third data set was OCR data of the British musical bibliography. A number of design decisions were applied throughout the implementation of the conversion of this legacy data into RDF. One was to have continuous updates. Workflows from the original to the processed data should be reproducible. And the other was to specify rather than to transform. So data is left as close to its original form as possible, with additional specifications to reveal the semantics in the data. The process of ontological modeling for the subsets included a bottom-up model that was extensively based on the existing data structures of the datasets that constituted in concert. In the case of Calendar of London Concerts 1750 to 1800, the classes of the underlying ontological structure were for the most part directly aligned with information types of the original data. So classes in the ontology contain as their instance data the content of a particular column from the original flat table. During a very iterative design process, the requirements of the data became more apparent. And it was then the possibilities of further semantic enrichment were identified throughout the process. Certain controlled descriptions or descriptors that have the potential to be semantically meaningful were left simply captured as unstructured plain text using things like the RDF's label predicate. And in some ways there is information within that system that only exists in a human readable format. And this is a design decision made to reflect the requirements and the limitations of time and scope of the project. In the case of this tabular data, the conversion of this information held in a CSV file to the turtle syntax of RDF was carried out using WebKarma, which is an open source software tool developed by the University of Southern California. Our workflow consisted of mapping between our imported OWL ontological structure and the data, and it was completed using the tool's graphical user interface. This workflow produced 95,000 triples, which was very high quality and required very little ad hoc fixing. The 19th century London concert life dataset was not in tabular data. Rather, it existed in a relational database. The data infrastructure supported the outputs of this information in a number of different formats, including HTML, also CSV, and JSON. The RDF that was produced from the second dataset was done so creating or using two distinct workflows. First, there was the ontological mapping using a tool called D2R, and there was a JSON LD exemplar. One of the main lessons learned from the Transforming Musicology project was that workflows that require greater investment of user time initially produce a higher quality set of triples. And even in the case of using an automated system, some user time is eventually needed, even if that is as an ad hoc solution at the end. The recommendations that came out of this project are really in line with trying to find tools and workflows that support the prior knowledge of the developer, the user, the RDF producer, and rely on things like existing systems and a known existing level of technical competence. My final and third case study example is JazzCats, or the Jazz collection of aggregated triples. This project brought together three completely separate datasets, one as the CSV or tabular data, one which is relational data, and the third which already existed as RDF. Applying the lessons learned from the previous projects, we use the WebKarma workflow for the tabular data of the discography of the body and soul jazz piece. We use D2R for the relational data of the Weimar Jazz database, which captured metadata of jazz performance. And we ultimately chose to ingest the pre-produced RDF that captured the prosopography of jazz musicians from linked jazz. The process of ontological mapping for JazzCats was one of reuse, where possible, of existing classes and properties from other known ontologies. These were then enriched where necessary by bespoke and project-specific classes and properties, which have now been published as a part of the JazzCats project ontology on GitHub. Rather than simply utilize the URIs from external authority files such as VIAF or Wikimedia, we chose to mint our own project-specific URIs and to align those with the equivalents from these aforementioned external authority files. These design decisions were informed by our prior experiences of working with linked data projects in the humanities. So rather than try and remove ambiguity or uncertainty, we chose to try and find ways to capture it. The main heuristics and bits of advice to take away, I suppose, would be that firstly, there are political, institutional, legal, and socio-cultural considerations to every linked data project. And it should be of fundamental importance that these are taken into consideration from the very onset of the project and not simply added as a box tick exercise at the end of a completed workflow. Secondly, the best tools and the systems to recommend are not simple and universal, but rather are those that most clearly and most effectively align themselves with the existing skills and the functional requirements and necessities of a particular project, a researcher, or a specific workflow. In other words, the tool that's best for you might not be the best tool for me, and vice versa. They might be if our skill sets, hopes, and desires for RDF align, but if they don't, there's real value in testing out different options and evaluating your choices until you settle on the tool that best works for you. And thirdly, in my personal experience working particularly with JazzCats, the ingestion of triples from another external project into our triple store ended up being the solution that we implemented, not because we felt that it was a theoretical or ideologically the most suitable option, but because this enabled us to exercise a degree of safety and protection against any kind of issues that we might encounter if the remote dataset was moved or taken down or was temporarily unavailable, for maintenance. This is something that I would strongly categorize as heuristics, something that I would implement for the practical outcome of having a functioning project, rather than one that I would recommend as a philosophical or theoretical ideal. And so in conclusion, I would just like to say thank you very much for giving me this opportunity to talk about, even if very briefly, my experiences of applying the linked data methodology to the humanities, arts, and social sciences landscape. I would be delighted to carry on this conversation, and so please do reach out to me, do contact me on social media. My Twitter handle is in the slides. I'm also Google unique, so finding my email address should not be an insurmountably difficult challenge. I hope you all have a fantastic rest of the event, and I hope to see you in various linked data events in the future.